today we are going to see our lab experiments, which is based on a convolutional neural network. The very first model that we are going to begin with is to simply design a CNN model, a basic CNN model, and we would try to implement it using multi-category JPEG images. Alright, so here for this we have chosen rice classification as a task, and the domain of it is an agricultural domain, and rice classification is therefore very important in agricultural domain. Looking at just the picture, it should be able to classify with you what type of rice it is. So it helps in grain quality assessment, which is a significant concern in agriculture. So the problem statement would be to design a CNN model, and the data set that we have used here is a rice image data set. You can use rice image data set, which the one that I am using here has got 75,000 images with 15,000 images of each rice variety. You have got varieties of rice, for an example, are Borneo, Basmati, Ipsala, Jasmine, and Karkadak. So these are all several varieties of the rice that we are going to check for classification. So the pipelining for your solution, or the process of your solution, should be: first you would be modeling this particular thing to concerned pixel value. So we have chosen here 28 by 28, and the image is a grayscale rice image, and obviously the label is the respective varieties of the rice. So first what we would do is we would load our data set using os.list directory, and you could see here I have got 6 classifications of 6 varieties of the rice that I can classify a particular image into. And for the pre-processing, we would check for the shape of input as well as the output, and we would normalize everything between 0 and 1, because that's what we want, a grayscale image of the rice. It is completely application based, so I am doing that. And post that, now we would define a particular model, very basic simple CNN model that I would be choosing here. Here I am using 2 pairs of convolutional layers and a pooling layers, of course, and then you can see a dense layer. So if I see the code very quickly, I'm using 2 convolutional layer and then post with an activation ReLU, and then I give one of the convolution layer my input, and I use a pooling layer in between. So I basically have 2 blocks of convolutions here followed by pooling. Then to avoid any sort of overfitting, I would be using a dropout. Finally, before I pass it through a fully connected layer, which is dense layer, I pass it on through a flattened layer, and then I would be choosing softmax, because this activation function would be useful for multi-category classification. When I compile this particular model, I'll be using categorical cross entropy as my loss function, and my optimizer I have chosen here is an Adam. You can check for different optimizer based on the accuracy standards while evaluating the performance, and check for the further results. Now if I see this particular model's summary, then total number of trainable parameters I get is around it's millions of parameters over here, and I have given here 20 epochs. With every increase in epochs, I could see the validation loss getting decreased and validation accuracy increasing. See, to avoid overfitting, what you have to see is training accuracy should be high as well as the validation accuracy should be high. Otherwise, your model will be overfitted. But we have used subsequently proper dropout layers, so I do not think it should be a problem. You can just play with your code and check. So now if I see, this is my final result, say 20 epochs. If I complete, I could see my validation accuracy as 99%, and of course my training accuracy is almost 99.6%. It's a very efficient model, CNN model, and the optimizer that I have chosen here is an Adam. You could also play with different optimizers, and you could see that, if you could get if your accuracy is deteriorating or whatever, because almost 100% accuracy we got here, 99%. So you can test. Now one thing that you can test over here is, again, you can just play with the model architecture, remove or add any dropout layers, okay, and subsequently check if there is some overfitting condition prevailing or not. So I think we have clearly demonstrated how to create a CNN, basic CNN model, and with TensorFlow it is quite very easy. So I would like you to play with this model and get an solution for